All right. Hello, my students. This is Mr. D coming at you with another math session. This time we're going to redo uh, this example for real life linear relations problem solving. Remember, we did this in class, so this one's going to be mostly a recap, but I did change some of the questions, okay? And I want to change it so that it focuses mainly on what it is that we're going to be learning or staying with in this unit. This graph, the linear relation part, that's going to come a little bit later. Okay, so I'll show you how to do the graphs properly later. Right now, let's go back to Bennett and his friends deciding to go bowling. The cost per group is $15 for shoe and lane rentals. Okay, plus $4 a game. Okay, as the advice I've given in class, when you're doing a problem solving question, at least look at the skills that I've already am teaching you in that unit. So, because it might be helpful. In other words, if we're in the linear relations unit right now, I'm not going to give you a question regarding statistics and probability. I just feel like that would not be fair. Okay, so I'm asking you to do a problem solving question that is most likely related to some lessons that we've already done on how to make a data table, how to determine an algebraic equation. So this one's any different. It just doesn't look as easy, but there's a way to be able to get this situation into these scenarios, like this situation where you can make a data table, okay, describe and get an algebraic equation, etc. You just got to know what to look for. Okay, so what might be important information in here? Not the name of Bennett and his friends. I mean, this is just a scene. I think the most important things to look for in the problem solving, maybe the numbers that might be helpful, like this $15. Maybe the this word plus and the $4 per game. Okay, those kinds of things. Those are probably because the word plus. Well, guess what? That probably implies an addition. Um, this three letter word here per. Believe it or not, actually in math that actually translates to a multiplication. Okay, as in $11 per hour, okay, like an hourly wage, right? So in this case, for every game, it looks like for every game they play, they're going to be charged $4 for it, on top of the $15 that they already spent just going in and renting the lane and the shoes. Okay, so look for those kinds of information when you're doing problem solving, and look for the skills that I've already shown or taught you in that unit because they will be helpful. Okay, so let's do this first step. It reads, it says for us to create a data table for this linear relations. What are the two things that are related in this linear relations scenario? Well, I think this is really about the cost, is it not? And maybe we'll designate that with letter capital C. The cost and I think the game are related because, give that little G, because if you ever ask somebody, like if Bennett took me as one of his friends to go bowling and he asked us to pitch in, well, I think one of the first things I'm going to ask is, well, how much is it going to cost? Right? So this is really cost calculation and depending on the number of games. So we can actually make a data table for this where the independent variable is the games and where the cost is actually the dependent variable because how much it costs depends on how many games we play. Yes? I'm going to skip some space here when I'm making this data table. Skip an empty space here. I'm going to go to 1. Okay, so let's determine how much it's going to cost if you just play one game. Well, we already spent 15 plus $4, one game, one. So it's going to cost us $19. Two games, well, that's 15 plus 2 times 4, because that's two games now. That's 15 plus 8. well, it's going to be 23. Okay, if we played 3 games, well, that's going to cost us $27, etc. What if we went in there and we never actually played a game? Kind of silly to think about, but what if we just paid our $15 to get in and we all just sat there and said, hey, we're just going to stay here and relax and watch other people play? Well, honestly, even if you didn't play in a game, you've already spent that $15 getting into the bowling alley. So at 0 games, you're still paid the $15. When you start playing, well, then that's when the additional cost of $4 per game comes in. Okay. So before we get to the algebraic equation, let's do a description of this linear relations. And again, my description, the way I want you to describe it is just to keep it simple. Okay, as the games increase by 1, in other words, as the games are increasing by 1, the cost goes up or increases by $4, or just say by 4. Okay, we'll say $4 because this is about money and cost. Okay, so now we're here. What is the algebraic equation for this? Well, as I've shown you in class, the easiest way to really do this is, well, this equation is going to be about the dependent variable always, okay? So because the cost is the one that's increasing dramatically. The game is just, well, that's just counting how many games you actually have. So this equation is going to be about the cost. And what is the cost equal to? Well, it is equal to the $15 you already paid plus the $4 per game that you're going to play. But to get this equation, really, by taking out the guesswork out of this, simply take whatever the constant increase is, multiply that by the independent variable, multiply it by g, and now we just got to figure out what the adjuster is. And the way I do that is either look at the 0 and see what we have, or if we didn't have this 0 part, then I would just take the first one. If we played 1 game, what is 4 times 1? 4 times 1 is 4. What do you have to do to 4 to make 19? Well, you have to add 15. Okay, and so that's our equation. Does that work with every single one? Yes, it will, because if we played 2 games, 4 times 2 is 8. What is 8 plus 15? 23. Maybe instead of jumping ahead to D here, maybe we should do a verify, because I did get you guys to practice verifying. In other words, proving that this is the equation for it. Let's see how much it would cost if we played 3 games. Our calculation should equal to 27. Okay. In other words, does 12 plus 15 equal 27? Yes, it does. So this is our equation. And now we can use this equation. We know it's true. We know it's the real equation. Now we can use it to calculate how much it would cost to play 6 games, for instance. Okay, so let's start with the equation. Cost equals 4g plus 15. We're going to substitute the 6 wherever for this g. Okay, so now we have 4 times 6 games. 4 times 6 games is going to cost us 24. But that 24 is already added to the $15 that we spent earlier. Just renting it. So we're going to have what, $39? Okay, so it will cost $39 to play 6 games. Don't worry about this graph the linear relations, but we're going to come back to this a little later. And maybe we'll start with these examples. I'll bring back the same example, and what we're going to do is we're going to graph this data table later on. Let's do this one. Use the equation to calculate how many games can be played if you have $50 to spend. Okay, so we'll start with your equation again. C equals 4G plus 15. Now this time we're going to substitute this 50 for the cost, because you're going to spend all your money. This is how much it's going to cost you. It's going to cost you $50. Well, how many games can you play with that? Okay, well, for that $50 you have, first of all, you're going to have to take out 15. Okay, so we're trying to solve for G right now, and the first thing I should do is just basic solving equations from grade 8, okay? It's like whatever this number is, magic number, we multiplied it by 4, added 15 to get 50. So we got to reverse what we did to it. Okay, so the last thing we did to it was add 15. So I'm going to subtract this 15 on both sides. And so 50 minus 15, that's 35. Oops, 35. Okay, and that's equal to 4G. So divide both sides by 4. And the number of games we could play with $50 is this 7.5. Okay, 35. 8. 8. And then 7.5. Yeah. 8.75 games. What is 8.75? Well, might as well round it up to 9 or 8. So G is equal to 9. So you can play approximately 9 games with $50. Okay. So again, I hope this video helps. This is just another example, like in case you want to do another, in case I give you another assignment on how to do problem solving, a real life example of linear relations. Just follow some of these steps and instructions, and I hope it does help you out. Okay, we'll practice again during class. Maybe I'll make another video this time. Other examples where instead of the cost increasing, maybe the scenario where the dependent variable is decreasing. Okay, so thank you for viewing this, and good luck. See you later.